Let's go over some trig identities now, a short introduction. So if we have a right angled triangle, we have the Pythagorean Theorem. And what this says is if we label the triangle A, B, C, the shorter sides being A, B and hypotenuse being C, then A squared plus B squared equals C squared. If we divide this by C, squared, we get A squared over C squared plus B squared over C squared equals C squared over C squared. Now A squared over C squared is the hypotenuse, is the opposite over the hypotenuse, which is nothing but sine squared. Theta, if this is theta, this is cos squared theta, and c squared over c squared becomes 1. So this is a very important identity that we need to learn. Note that it's not sine theta squared plus cos theta squared. So this means that we get the sine of theta and then square, whereas this means we get square theta and then sine of theta squared. So we must always write it like this in the box. If we now take this sine squared theta plus cos squared theta equals 1, and we rearrange, so rearranging it we get sine squared theta equals 1, moving the cos over to the other side of the equal sign, and we've got cos squared theta. So that's another important identity we need to know. If we rearrange again, keeping the cos squared over on this side, we get cos squared theta equals 1, moving the sine squared over to the other side, we get minus sine squared theta. So that's another identity we need to know. Now if we divide over here sine squared theta plus cos squared theta equals 1 by cos squared theta throughout, we get sine squared theta divided by cos squared theta is tan squared theta plus cos squared theta over cos squared theta becomes 1, and this equals 1 over cos squared theta, which is sec squared theta. So that's another identity. Similarly, we can rearrange that and we get tan squared theta equals sec squared theta minus 1. So we're moving the 1 to the other side of the equal sign. And similarly, if we divide through by sine squared now, we get sine squared over sine squared is 1 plus cos squared over sine squared is cotangent squared theta equals, and 1 over sine squared theta is cosecant squared theta. So that's another identity. And then lastly, let's rearrange that, keeping the cotangent squared theta on this side. We get cosecant squared theta minus 1. When we are looking at two triangles and we want to find the sine A plus sine B. So for example, here we have two separate triangles. As you can see, if we combine them like so, the sines of the two triangles, the sine of A and the sine of B, when projected onto the y-axis, would not be the same as sine A plus sine B. So how can we make a formula to work out the sine of A plus the sine of B? Okay, so the combined sine is this component x plus this component y of the two triangles. As you can see, when projected onto the y-axis, this would give us the sine value. In this, we have to realize that this triangle here in red and this triangle here are in fact similar triangles. So this angle here is A, and this is the same as the sine of B. This is the sine of A. This is a right angle. So from these we get, this would be cos B and this would be cos A. So to get x, we have, for using this first triangle, we have cos A equals x over sine B. So x equals cos A sine B. Because we have similar triangles, the sine of A equals, now this is for the larger triangle, y over cos B. So y then becomes sine A cos B. So the combined x and y, which gives us sine A plus B, then becomes x, which is cos A sine B, plus sine A cos B. If we look at the same situation again, but for cos A plus cos B, in this situation the cos of A plus B is this, from here to here. This is y, and this whole length is then x. This is A, sine B, sine A, cos B, and cos A. So in this situation we get cos of A equals x over cos B. So x equals cos A cos B. Because of the similar triangles, we get sine A equals y over sine B. Y equals sine A sine B. So cos A plus B is then cos A cos B minus sine A sine B. Look at the angle sum and difference identities. Then, as we saw in the previous video where we proved the angle sum and difference identities, then sine A plus B equals sine A cos B plus cos A sine B. For the difference we get sine A minus B, and all we do is we reverse this plus and make it a minus, so it becomes sine A cos B minus cos A sine B. For the cos, we have cos A plus B. cos A cos B minus sin A sin B, and similarly when we get the difference of the two, we have cos A cos B plus sin A sin B. So those are the angle, sum and difference identities. Also for tan A plus B, it's tan A plus tan B all over 1 minus tan A tan B. Double angle identities. By double we mean sine 2A. So this again follows from our previous angle, sum and difference identities. So remember, for sine A plus B we had sine A cos B plus cos A sin B. So if we have this double angle, which is essentially sine A plus A, we have sine A cos A plus cos A sin A, and this becomes 2 sin A cos A. So sin 2A equals 2 sin A cos A. Now what about the cosine double angle? So cos 2A. Cos 2A, again, we have cos A plus B equals cosine of A cosine of B minus sine of A sin B. So if we have double that sine cos 2A, so we have cos A plus A, we change all the B's to A, so that becomes cos A minus sin A sin A, and this is cos squared A minus sin squared A. So cos 2A is this identity. Also, from our identity sine squared theta plus cos squared theta equals 1, if we replace the cos squared theta by 1 minus sine squared theta, which is equal to the cos squared theta minus sine squared theta, and this is 1 minus 2 sine squared theta, which is another identity. Similarly, if we replace the other here we replace the cos squared. If we replace the sine squared, we get cos squared theta minus 1 minus cos squared theta, and that becomes 2 cos squared theta minus 1. Whereas the theta can be replaced with alpha or a. So let's do that. So that's 2 sine squared a, 2 cos squared a minus 1. Look at the half angle identities. So previously we saw that in the double angle identities, cos 2x equals 1 minus 2 sine squared x. So that's the double angle identity. If we rearrange that, we get sine squared x equals 1 minus cos 2x all over 2. So that's the first of our half angle identities. Now if we replace this sine squared x using our identity sine squared x plus cos squared x equals 1, sine squared x is nothing but 1 minus cos squared x, and that equals 1 minus cos 2x all over 2. When we rearrange that, we get 1 minus cos 2x equals 2 minus 2 cos squared x. And then when we take this to the other side, we get 1 plus cos 2x equals 2 cos squared x. And this then is our other half angle identity, 1 plus cos 2x over 2. When we're trying to prove trig identities, or asked to prove trig identities, some tips to bear in mind. First of all, choose a side that to you looks messy. When you start to prove the trig identity, never cross over. So don't go from one side to the other, always follow it down, and then if you need to, put a line and then go down the other side. 3. Get common denominators. And combine like terms. And 4, if the denominator is a binomial, multiply by the conjugate. So let's have a look at some examples. Okay, for example, if we have cosec theta equals cosec theta minus 1 over 1 minus sine theta. So first of all, we choose the side that looks most complicated, which is the right hand side. So we're going to choose the right hand side, and we try to simplify it into cosines and sines if possible. So cosec theta is nothing but 1 over sine theta minus 1 all over 1 minus sine theta. This one we can consider as that fraction to make it into a whole one. Now what we need to do is multiply this by 1 essentially, which is sine theta over sine theta. So sine theta over sine theta becomes 1, and here we have sine theta, and on the bottom we have sine theta minus sine squared theta. Let's factor out a sine theta from the bottom, so we have 1 minus sine theta. So we're going to factor out a sine theta, and this becomes 1 minus sine theta. This 1 minus sine theta cancels with this to give 1 over sine theta, and this equals 1 over sine theta is cosec theta, which is the left hand side. 1 minus cos x over sin x equals sin x over 1 plus cos x. So first of all, let's choose a side which looks a little bit more complicated. So we're going to choose the right hand side, and we're going to simplify that. Notice that we've got a binomial on the bottom, so if we get sin x 1 plus cos x, and then we multiply that by the conjugate, so that's the conjugate of 1 plus cos x is 1 minus cos x, and we have to do the same to the top, 1 minus cos x. So when we multiply those two together, we get sin x minus sin x cos x on the numerator, and that's all over 1 minus cos x squared. Here we can factor out a sin x, so we get 1 minus cos x. So that would become sin x minus sin x cos x if we got rid of the brackets. So we'll just factor out sin x. And the 1 minus cos x squared from our identity, which is cos squared x plus sin squared x equals 1. The 1 minus cos x squared is nothing but sin squared x. So we've used this identity to replace that denominator. Now this sin squared and the sin x there cancel. So this becomes 1 minus cos x all over sin x, which is the left hand side. In this example, cotangent of x minus cosecant x equals cos 2x minus cos x all over sin 2x plus sin x. So what to do? We have a mixture here of things that we can reduce to sine and cosine. So let's first of all start on the left hand side. So on the left hand side, cot x is cos x over sin x minus cosec x is 1 over sin x. This, because we've got common denominator, we can write as cos x minus 1 over sin x. Now let's have a look at the right hand side. So on the right hand side we've got cos 2x over sin 2x. So from our identities we know that cos 2x, let's choose one that has a cos in it. So that'll be 2 cos squared minus 1 minus cos x all over. Now the identity for sin 2x is 2 sin a cos a, 2 sin x, sorry there should be an x there, sin x cos x plus sin x. Now when we look at this, the numerator is a quadratic, something like 2x squared minus x minus 1, and when we factor this we get 2x plus 1 and x minus 1. So we can do the same to the top of the numerator. So when we factorize we get 2 cos x plus 1 and cos x minus 1. Those are the two factors that give us 2 cos squared x minus 1 minus cos x. And when we factor out a sine x. From here we get sine x 2 cos x plus 1. So we have a 2 cos x plus 1 on the top and a 2 cos x plus 1 on the bottom, and this leaves us with cos x minus 1 all over what's left there is sine x. So the left hand side equals the right hand side. For example, cosec theta minus cot theta all squared equals 1 minus cos theta all over 1 plus cos theta. So cosec is nothing but 1 over sine minus cotangent is sine, tangent is sine over cosine, cotangent is cosine over sine, so that's cos theta over sine theta squared. We have a common denominator, so we can write this as 1 minus cos theta all over sine theta squared, which becomes 1 minus cos theta squared over sine square theta. So that's our left hand side. So let's have a look at our right hand side now. So for the right hand side, 1 minus cos theta over 1 plus cos theta. We notice that we have a binomial on the bottom, on the denominator, so we can use the conjugate. So that's 1 minus cos theta over 1 plus cos theta multiplied by, and the conjugate is 1 minus cos theta 1 minus cos theta. When we do that, we get 1 minus cos theta squared, and on the bottom in the denominator we get 1 plus cos theta 1 minus cos theta. Now when we look at the denominator, we can see that it looks a little like when we take the difference of 2 squared, we get a squared minus b squared equals a plus b multiplied by a minus b. So doing the reverse of that, we get 1 minus cos theta squared all over 1 squared minus cos square theta. Or we can, 1 squared is just 1 minus cos square theta. Now from our identity, sine squared theta plus cos squared theta equals 1. This becomes sine squared theta so our right hand side now becomes 1 minus cos theta squared all over sine squared theta. So the left hand side equals the right hand side. A plus B, A minus B, and that is from the difference of two squares, which is A squared minus B squared. When we're asked to solve equations which involve trig functions, it's good to bear in mind our cast diagram, which is a circle split into 4, C, A, S, T. So this means that in quadrant 1 both sine and cosine are positive, all are positive, and tangent is positive. In this quadrant 2 only sine is positive, in this quadrant 3 only tangent is positive, and in this quadrant 4 only the cosine is positive. Also, let's draw a quick diagram of our common angles: 30 degrees, 45 degrees, 60 degrees, 1, 2, 3, 3, 2, 1, over 2, square root of 3 over 2, square root of 2's, and square root of 3. And this gives us the values for the sines. So the first one will be this cosine, and then the sine of 30 degrees, 45 degrees, and 60 degrees. So if we're asked to solve 2 sine theta equals square root of 3, and we're going to do it for the range 0 to 360 degrees, then sine theta equals square root of 3 over 2. If we draw our little quadrant, sine theta is positive, so where would it be positive? It would be positive in our first quadrant and in our second quadrant. So all and sine positive. The angles that we're concerned with would be the acute angles here. So let's have a look here now. So theta would equal sine to the minus 1 square root of 3 over 2, which is 60 degrees. So this would be 60 degrees, and this would be 60 degrees. So when we go round, so this would be an answer, and also this would be an answer. In the other quadrants, sine is not positive, so there would be no answer there. So the answer we'd get is 60 degrees, and then 90 plus 30 degrees, which is 120 degrees. Tan theta equals square root of 3. Now we're given a range as well, and the range is minus 360 theta 0 degrees. So we have to give the answer for theta within those ranges. or within that range. So if we have a look for tan theta, it's positive. So if we draw our little quadrant diagram, where is tan theta positive? Tan theta is positive in quadrant 1, where all are positive, and also in quadrant 3. So we bring this line down here. This is the angle theta that we're interested in, and also this angle theta, the acute angle from the horizontal. If we do theta equals tan inverse square root of 3, we get 60 degrees. So this is 60 degrees and this is 60 degrees. Now the solution, we're going from 0 degrees to minus 360 degrees, so we're going anti-clockwise. So one of the solutions would be from 0, which is here, going round this way to here, and then minus 360. Another solution would be from here, 0 again, we're going round the circle and to here. So the answer, or the solution, is 180 minus 60 degrees, which is minus 120 degrees, and then for the green, 360 minus 60, which is minus 300 degrees. Sec theta equals minus 2, and the range is minus 180 degrees, 180 degrees. So let's have a look here. So sec theta is nothing but 1 over cos theta, and so cos theta is minus a half, and we'll take the reciprocal. This is, cos theta is negative, so if we draw our quadrant, where would it be negative? So it would be negative in the second quadrant, and also it's positive here, all are positive here, it's negative here, only tangent is positive here, so it's negative in the third quadrant. But these two angles are the same. So when we get theta, which is cos minus 1 and minus a half, we get 120 degrees. So obviously this angle, or this angle by itself, can't be 120 degrees. So this angle is 120 degrees. So that is theta. So when we're giving the two answers for theta, we have to give that one and also the one that goes to from 0 to minus 180, which is that way. So the answers are theta equals 120 degrees, and also when we go anti-clockwise, theta equals minus 120 degrees. let's have a look at some examples of solving equations using trig identities. First of all, let's solve 2 sine t squared plus sine t equals 0. Now they give us the range is between 0 degrees and t and 2 pi, from 0 to 2 pi. So what do we do? First of all, we see that this actually looks like a quadratic to start off with. It looks, if we replace the sine t with x, it's like 2x squared plus x equals 0. Let's put this in a little thought bubble. If we factor out the 2x, we get x plus a half equals 0. So in this case 2x equals 0 and x plus a half equals 0. So instead of x we're talking about sine t. So sine t equals 0 and sine t equals minus a half. So let's draw a little quadrant diagram for our solutions. So these are our solutions. When sine t equals 0, so the sine is the projection onto the y-axis, so it'll equal 0 at 0 and also at pi. If we think of this as a sine curve, and we're going from 0 to 2 pi, so this is 2 pi, and our 0 is here, so it's here and here. So this is pi, this is 0. So it's at 0 at 2 places, so t equals 0, t equals pi. Now what about when sine t equals a half? So sine is negative. Where in these quadrants is sine negative? Well, sine is negative in quadrant 4, all positive there, sine is positive there, and in quadrant 3. So when sine t equals minus a half, t is pi over 6. So this angle is pi over 6, and this angle is pi over 6. So the angles that we're interested in as the solutions are from 0 all the way around to here, and then the second one is from 0 all the way around to here. So in the first case this is 7 pi over 6, and here it's 2 pi minus pi over 6, which is 11 pi over 6. So those are our 4 solutions. Okay, solve 2 sine squared t minus cos t equals 1. And we're given the range again 0, so t is between 0 and 2 pi. So what do we do here? So we can use our identity, sine squared t plus cos squared t equals 1. This sine squared t equals 1 minus cos squared t. So that's our little identity we're going to use for here, where we've got sine squared t. So this becomes 2 sine 1 minus, we're going to replace that with 1 minus cos t, 1 minus cos squared t minus cos t equals 1. Get rid of the brackets here, we get 2 minus 2 cos squared t minus cos t equals 1. Now this looks like a quadratic with the x being cos, so this would be x squared, this would be x and some numbers. So let's make it equal to 0. So we have 2 cos squared t minus cos t minus the 1 equals 0. So if we solve this like we would solve a quadratic, we could put x instead of cos. We get 2 cos t minus 1, and we get cos t plus 1 equals 0 as our two factors. Now both this, which is the 2 cos t minus 1 is 0, equal to 0, and this cos t plus 1 equals 0. Therefore our t, or our cos t, the x, equals a half in this case, and in this case cos t equals minus 1. So let's have a think about this. So where does cos t equal? Let's go for minus 1 first. So the only place that it would equal minus 1 is here at pi. So our first solution would be pi. Think of this if we draw a quick, we've got 1 there, minus 1 there, and our cosine curve comes like this. So minus 1 would be here, which is pi. Now what about a half? Cos t equals a half. Well, first of all, where would cos be positive? Well, it would be positive in the first quadrant where everything is positive, and it would be positive in the fourth quadrant where cosine only is positive. The angle we're interested in is here. So when cos t equals a half, this is pi over 3, and this is pi over 3. And the solutions we're interested in is pi over 3, which is up to here, and then also going round to over here. So the solutions are pi over 3, and 5 pi over 3. Okay, we're going to solve tan x equals 2 sin x, and given the range between 0 and 2 pi. So going to use our ratio, which is tan x equals sin x over cos x. So tan x becomes sin x over cos x equals 2 sin x. Now what can we do? We can multiply both sides by cos x. So when we do that, on this side the cos x's cancel out, and we're just left with sin x, and on this side we're left with 2 sin x. and then the cos x that we multiplied by. We can now bring this over to the other side. We get sine x minus 2 sine x cos x equals 0. Factor out a sine x. Get 1 minus 2 cos x equals 0. So here we get this sine x will equal to 0, or 1 minus 2 cos x equals 0. So here we have, where does sine x, so here we have sine x is equal to 0, cos x, so cos x will equal a half in this case. And cos to the minus 1 of a half is 60 degrees. Sorry, we're going to go sine x equals 0. So sine x will equal, sine x is a projection onto the y-axis, so it equals 0 here, so there's no projection onto the y-axis, so that'll be 0. And also at this point here, which is pi. So that's when sine x equals 0. What about when cos x equals half? So, well, it's positive, so it's going to be either on quadrant 1 or quadrant 4. And this angle equals this angle, which is 60 degrees. And we're interested in this as the solution, or going all the way around from 0 to here. So our solutions are 0, pi, 60 degrees, and then 360 minus 60 degrees, which is 300 degrees.